Here we have a second example for the compound and inequalities. Once again, I've solved two statements, two inequalities, to come up with their solutions, and they're joined with the and statement, meaning that both of these must exist at the same time. So I'll begin with my number line. As I draw my number line, I do indicate 0, which is the most important number on a number line. And this time I locate 3, which should be an open circle. And the statement is telling me to shade off to the right. Next I need to locate the -7, which would be a closed circle because it has equality. And I shade this off to the right as well because it's pointing to the right. The objective for an and compound inequality is that you can only shade where there's overlap, where both expressions exist at the same time. So when I'm over here, there's no expressions, there's no shading. From -7 up to 3, there's only this one statement, so there's no shading. At 3 itself, this is a ghost point. It's a hole. It doesn't really exist there. So that means that I cannot shade at 3. I would have to leave that as an open circle. But as you note, anything beyond 3 has both of these statements existing at the same time. And so what I should do is shade anywhere both statements exist at the same time. That is the significance of your compound and inequality and your shading. If I have a number shaded, it guarantees it must solve both statements. That's the essence of a compound and inequality. And there's your second example where you end up with nothing more than just a one arrow solution.